All right, you also graphing rational functions day 2. My goal today is gonna be to stop saying my ums and uhs and everything like that. So we'll see how it goes. Let's go ahead and try it. So with graphing rational functions, all right. There it is. But the last part that we need to do is find some different pieces and different points in order to actually get the general shape. So that's what we're going to do today. We're also going to work with the domain, which is relatively simple. Okay, so let's go ahead and begin. I'm going to use this sheet again. You definitely want to have this handy. Okay, you definitely want to have that handy while we're working with this, especially while we're learning in the beginning, just trying to get the hang of the situation. So we are going to start with the domain on this first one. Okay, we'll just start with the domain on this first one. I'm going to have a scratch paper here. We're going to need a decent amount of scratch paper for this particular one. And I'm going to try to keep everything nice and neat over here in the actual notes. Why does it keep doing that? Stop it. Okay, so here we go. Let's go ahead and start with the domain. All right, so the domain in our section here, right, is right here, okay, and it says before reducing, set each factor of the denominator equal to 0. Notice it's the denominator, and then you're going to take out those values, these x values, when they're set equal to 0, those must be taken out of the domain. So it's very similar, if you remember, to just kind of when we were working with domain and range with just parent functions in general. Okay, we noticed that anytime we had something on the bottom, right, you can never divide by 0, so you have to take out that value because you can't divide by 0. Okay, so that's what we're going to do with the domain for each of these, because if you have something with x on the bottom, then you've got to take out that value. So with number 1, okay, on our work with the domain, we're going to go ahead and set x minus 5 equal to 0. X minus 5 equal to 0, and then in order to solve here, we're going to add 5, and that value x equals 5 we're going to remove from the domain. Now this actually makes it pretty simple for us because all we have to do is put it into set builder notation here, right? And we'll say that x such that, okay, x can't be that value of 5, and that's the only one we have to remove, right? The only reason there is just because you cannot divide by 0, and the value of x that will give you a 0 on the bottom is 5. So 5 minus 5 here, that's why we take out that value of the domain. So there's the domain. All right, with the x-intercepts. All right, so the x-intercepts says set the numerator equal to 0 and solve. Right, your x-intercept as a coordinate number, right, comma 0. And I want you to kind of note that this is actually after reducing. Sometimes, right, when you have a whole, right, you have to cancel out those two factors on the top and the bottom. I want to make this note after reducing because if you don't do that, you're going to end up having like a 0 over 0, and you just don't want to have that happen. Okay, so I'm going to go ahead and say after reducing just to eliminate that situation. Okay, so with the numerator, all right, we'll go ahead and set that equal to 0. And so we'll go ahead and have our function here. On top here, we've got 2x. So 2x, this is our work for the x-intercepts. Okay, we've got 2x is equal to 0. Okay, and then we just have x is equal to 0. Okay, and that's it. All right, so for this particular x-intercept, it's a little bit weird, okay, but we're going to have that value x, which we got here, so it's 0. It's going to be 0, comma 0, which goes ahead and tells us that this is also the y-intercept. All right, if you think about it, right, if it's the x-intercept, it also has to, and it's at 0, comma 0, it also has to intersect the y as well. Okay, so that's kind of a funky one, but we'll look at other examples to kind of clear that up in that regard. Okay, so that's the x-intercept. Cool. Moving on. Okay, and now we already have the y-intercept. Y-intercept would have been the same, but I do want to point out, I guess, just to show you the work of what we'll actually typically do, right, is we're typically just going to substitute 0 for x and then simplify, right? Your y-intercept as a coordinate. So let's just double check. Let's do the work how we are supposed to, right? You've got your f of x, and really what we're doing is finding f of 0. We are plugging in 0 into the function, and so we've got 2 times 0, okay, and then over 0 minus 5. So let's look at what we have. We have 2 times 0, that's 0, and we have 0 minus 5, that's negative 5. Okay, so this whole thing ends up being 0, which makes sense. Okay, so that does clear up why these are both 0, comma 0. Now, one thing I do want to mention about the x-intercepts, I want to go back a little bit, is just to think about why it's the numerator that we set equal to 0. Okay, so if we have a rational function, we've got some parts, right, like pieces on the top, and then we've got pieces on the bottom. Okay, the reason why we set the numerator equal to 0, and we don't care about the denominator there, is because it doesn't matter what the denominator is, right? If the numerator is 0, right, it could be 0 over 10, which is still the entire thing, 0. Okay, or it could be 0 over 105, right? Well, I don't care what's on the bottom; it's still 0. Okay, so that's why we want to focus on only on the numerator for the x-intercepts. Now, technically, you could just set the entire thing equal to 0. You're going to end up with just solving for the numerator there. Okay, I just want to point that out. All right, and then additional points. This is the last step, right? We want to find some additional points. Now, this is just to get an idea of what we're looking at, okay? And this is essentially what we're going to do is just plug in various different spots, okay? And the reason is just to kind of complete what the picture would look like. But let's go ahead and start with actually plotting these two, just so we have it. All right, so 0, 0, and then 0, 0. So we really only have one. So we don't have a whole lot of points here. All right, and that's why we're going to find some more. Okay, so that's what we're going to do here. Additional points. Okay, and me personally, I just kind of pick like 1 or 2, depending on the situation around this spot. Okay, I wrote down some of the ones I wanted to pick. So we'll go ahead and look at maybe x is equal to -2. Okay, so that's over here. We'll get a good idea of what that kind of curve is looking like. So f of -2. All right, so we're going to go back here to our equation and plug it in. Okay, so up top I've got 2 times -2 all over -2 minus 5. All right, so I'm just simply plugging it in, right? Anywhere I see an x, I'm going to write -2. So here I've got 2 minus 2. No, sorry, 2 times -2. So I've got -4, and then over here I've got -2 minus 5. Okay, so all over. Is that really the value I wanted? I guess it was. Okay, so 2 times -2. That's not the value I wanted, but that's okay. We're still going to have it. 2 times -2, -4, and then -2 minus 5 is -7. So kind of a funky one. 4 over 7, though, is my fraction. Okay, so it is about here, right? It's a little bit more than a half, so it's somewhere in here. Okay, so that kind of does give us a little bit of an idea of what it might look like. Okay, and then maybe we want to plug in f of 4. That's a better one. I was looking at the wrong question. But, and that's kind of really how you would be doing it, is you're just kind of picking a random one and then just testing it just to see where your values end up. So over here we had 2, okay, times 2 times 4, and then we got 4 minus 5. All right, so we got 8 over, this one gets you a nice and neat number. 4 minus 5, that's -1, and then 8 over -1, that's -8. So we have the point 4, comma, -8. All right, so here's 4, and then -8 is here. So that's kind of a drastic little jump there. All right, and essentially what you're going to do is now you have a few points. You just need 1 or 2 around it in order to get the shape. You're going to use your asymptotes to guide you, okay? And your curve is going to look like something like this, where you just touch a few of those points. Okay, is it perfect? No, but you're just trying to get an idea of what you're looking at. Okay, that's the whole point of this. All right, so some more additional points. All right, maybe we want to find these ones up here. Right, the rational functions kind of have that shape like this, and then it'll additionally be that one. So maybe let's just find two more up there. We'll do the points 6 and 7. That seems the most reasonable to me. I'm just kind of looking at them and determining which ones I think would be good ones to do. Okay, so f of 6. All right, I've got 2 times 6, and then on the bottom I've got 6 minus 5. Okay, so I end up with 2 times 6, that's 12. 12 over 1. Okay, there it is. So 6, comma 12. All right, so it's off the graph, but just to estimate, it's somewhere up there. And then for 7, f of 7, okay, again, 2 times 7, and we've got 7 minus 5. Okay, we've got 14 on top. We've got 2 on the bottom. So we also get a 7 there. So 7, comma 7, that is right here. And to estimate, we know it's going to look something like that because of that asymptote there. Okay, so that's what we're doing with the additional points. We're just trying to get a better, more accurate idea of what the rational function looks like. There's that one. Okay, so I probably do maybe one more of these. I mean, really, it's the same thing each time. Maybe the situation changes a little bit, but I'm thinking maybe I'll just do one more in the video and then just post these notes, just to, because I think this one we don't really need more information. It really is the same thing each time. You're finding the domain, right, and then you are finding the x-intercepts by putting the numerator equal to 0. For the y-intercept, you're plugging in 0, and then for the additional points, you just kind of estimate from there. Okay, so probably the ones that we should do. I'm going to go ahead and skip over to maybe one point that we can make here about 2, and again, I'll post it, but I won't actually do it in the video just to save you guys some time. Maybe the one that we should talk about is just to mention that there's a hole here. Okay, so in the video, just to talk about it in this video, there is a hole here, so just keep that in mind as you are graphing, right? You're going to find some additional points, you're going to find the y-intercepts, you're going to find some x-intercepts, but when you get to this hole, you're just going to leave it. You're going to go around it, right? We don't have a point there. It is not evaluated there because if you remember this one the other day had a factor that canceled out. Okay, so that's why you have a hole there. All right, let's talk about 3 then. Maybe I'll post that one. I'll just save you guys some time. Okay, number 3. All right, some of the points. Well, let's start with the domain. Okay, the domain, you want to take out those denominator values that make 0 on the bottom. All right, so with that domain, again, this is before reducing. That one was already in factored form. You set the denominator equal to 0, and then you solve. So let's do it. We've got x, this is the work for number 3. We've got x minus 1 is equal to 0, plus 1 plus 1. That value we want to take out of the domain. Okay, so we've got x such that x cannot be 1. That's my domain. X-intercepts. All right, for my x-intercepts, again, using these notes just in case. Okay, we're going to set the numerator equal to 0. Okay, again, if you forget that, right, just think about what an x-intercept is, right? Don't forget that your x-intercept is where it intersects the y-axis. So just a quick sketch, right? X-intercept would be something like that. Okay, well, what is your y value there? Your y value there has to, we don't know what x is, so x, comma, 0, right? Your y value is 0. Okay, so again, quick sketch to kind of remind you. Okay, well, that means my outcome has to be 0. How could my outcome be 0? Well, that's if the numerator were to be 0. So that's kind of the logic there, right? And that again goes to that whole thing you've probably heard me talk about is the whole, the whole don't memorize it thing. Kind of understand where it's coming from. Understand why this math makes sense, right? If you can do these kinds of things, you can repeat and you can kind of work off the hip a little bit and actually kind of work your way through it in case you forget the memorization. Because this is, if you're just going to sit here and memorize it, this is a ton of stuff to remember, right? But if you understand the math behind it, the reasoning behind some of this, then you can kind of work with your knowledge and piece it together. Just a quick thought on that. Anyways, with the x-intercept, you're going to set that numerator equal to 0. Well, you're actually going to find here that x squared minus x plus 1 equals 0. You're going to get a little bit stuck, right? Because we determined yesterday you actually can't factor this, okay? And even if you were to put it in the quadratic formula, you're actually going to get imaginary numbers, okay? Because you're going to have to end up taking the square root of a negative number. So I'll go ahead and tell you this one actually doesn't have an x-intercept. And if you were to graph this and see, right, it's not going to intersect the x-axis. So if the numerator can't ever equal 0, okay, then you don't have any x-intercepts. Okay, and that's possible that that's the case. That happens every once in a while. All right, y-intercept. Y-intercept, we're just going to plug it in. So I've got f of 0, and we've got 0 squared minus 0 plus 1, all over 0 minus 1. So 0 minus 0, I've got 1 on top, and then over negative 1. So this entire thing is negative 1. Okay, so my y-intercept is 0, comma, negative 1. There's my work for that, and I just realized my face is all over it. Okay, but anyways, all I did here is plugged in 0, okay, in for where I saw x. Okay, there's that. All right, you can go ahead and graph it. Put that point on, so 0, comma, negative 1. There it is. All right, some additional points. Maybe we can kind of fill it in a little bit. Some of the ones I picked earlier, you probably want to get maybe f of negative 2 here. Okay, and then just kind of toss it into the function, see what happens. All right, so I'm working up here. We've got, I'm going to kind of go through this quick. Negative 2 squared, that's 4. Okay, minus negative 2, so that's plus 2. Right, minus negative 2, so that's plus 2, and then a plus 1, and then all over negative 2 minus 1 is negative 3. I've got 7 on top, all over negative 3. So that converts down to about 2 1/3. Okay, so we can go ahead and graph that one. Let's get rid of this. We don't need this for now. We can go ahead and graph that. So again, negative 2/3 here. So negative 2 for my x, and then negative 2/3. So it's very close in here, right? You can kind of see that the asymptote is in play there. And maybe to just double check, go ahead and plugging in like 1/2, right? And I'm just picking these values just based on where it is. So 1/2 is right in here. So we'll hope, theoretically have something down in this vicinity. So we've got 1/2. This one's a little funky. We are going to use some fractions here. But we've got, let's see, so 1/4, right? 1/2 squared, that's 1/4. 1/4 minus, okay, 1/2, and then plus 1 all over 1/2. 1/2 minus 1, so that's negative 1/2. Okay, over here, we got 1/4 minus 2/4, right? That's 2/4 there, so 1/4 minus 2/4, that's negative 1/4 total. Negative 1/4 plus 1, that's going to give me a positive 3/4 on top, and then on the bottom, negative 1/2. So in other words, this is equal to negative 6/4, which is 1.5. Okay, right? So negative 1.5 is what that one ends up being. Okay, so we've got 1/2. Okay, and then negative 1.5. So it wasn't as close as I thought or remembered, but there it is. It is at 1/2 there. So you can kind of see the shape. All right. And again, not perfect, but I'm just trying to get some of the points, right? I'm just trying to get a few points that would work out. So there it is. And on the other one, maybe let's just do one. Let's do f of 2, just randomly picking, right? Maybe you do f of 3 or f of 4 just to get a general picture. But f of 2 here, we can plug it in. We've got 2 squared minus 2. Okay, so 2 squared minus 2. And then we could do plus 1, okay, and then 2 minus 1, okay, but anyways, 2 squared is 4, 4 minus 2 plus 1, I'm doing more work for this one for whatever reason. 4 minus 2, 2 plus 1, okay, that's 3 for the entire thing. 2 comma 3. Okay, and so you can just do 2, comma 3 and put it in there. We kind of get one of those middle points. All right, so we know it's up in this corner for sure. So then we'll just kind of estimate right there. Okay, that's what the function looks like, something like that. All right, and theoretically, right, it's probably a little more of a smoother curve, okay, as opposed to like a straight line. But that is that one. And then just thinking about number 4, looking at the picture, I do want to go over this one because of the kind of double asymptote. Okay, so with that double asymptote, makes it a little bit weirder, right? It's a little more uncertain. Maybe we're used to seeing, with these where it kind of splits it up into 4 sections, but this is a lot more sections here. So maybe it's a little confusing, but it's the same process. Okay, we're going to find some of the additional points based on what we already have with our x and y intercept, and then kind of piecing it together. And then also it's good to do this one just because maybe those slant asymptotes are a little bit weird at times and a little bit uncomfortable because we haven't seen that before probably. Anyways, number 4, we'll work on that one. Again with the domain, okay, with that domain, let's get a new sheet. But with the domain, same situation. Okay, what we're going to do with the domain is we are going to take out those values on the bottom. And so notice this one not in factored form right now, so we can convert it quickly. X minus 3 on top, and then hopefully we're getting good at this by this point, but x plus 5 and x plus 2 on the bottom. Again, numbers 5 and 2 multiply up to get 10, but they add up to 7, so that's why I get that. So now I'm in factored form. For that domain, I will take out values that give me zeros here. So you're going to have 2 different ones, right? If they cancel, right, then you're also going to take that out, okay? So I do want to mention that with the domain, when you take out a whole, right, you also want to take that out of the domain. So you want to do this before finding your domain. Let's use our sheet. You do want to do this before, right? Essentially, yeah, but before reducing. There it is. Okay, so before reducing, you want to set each factor in the denominator and remove it, right? And that's just because, right, the wholes are taken out of the domain, right? There's no x value when there's a whole, and there's no x value where there's a vertical asymptote. All right, so before canceling there. Anyways, with the domain, this one, I'm not going to set it equal to 0. I'm just going to write it. If you are cool with that, -5 will give me a 0 here, and then -2 will get me a 0 here. Right? You can also sort of reason through it. You don't have to do the algebra and show literally each step on those specifically. Okay, so the domain x such that, I'm going to split this into 2 pieces, right? X such that it's not -5, and then such that it's not -2. Okay, so those are the 2 pieces I will take out there. Okay, cool. X-intercepts. For the x-intercepts, okay, you're going to set that numerator, okay, equal to 0. And again, the reason we can remember that is we want this whole thing to be equal to 0. Well, when does this whole thing equal 0? When the top is equal to 0. So x-intercepts, again, maybe we reason through this one, right? Technically what we're doing is we're setting x minus 3 equal to 0, and then we get that x is equal to 3, but maybe we can do that process pretty quick. Okay, so my x-intercept here is 3, comma, 0. Okay, y-intercept. Y-intercept is where we'll plug it in. Y-intercept is where we will plug it into the actual equation, so f of 0. Okay, so I've got, and I would personally, I'm going to plug this into factored form, right? I don't like, personally, I don't like dealing with these, so I like factored form better, but technically, I mean, you can do whichever you feel more comfortable with. Okay, so we've got 0 minus 3 on top, okay, and then on the bottom we've got 0 plus 5, and then 0 plus 2. Okay, so on the top I've got -3, on the bottom I've got 5, but then times 2. Okay, so I end up with -3 over 10, which will give me, the decimal of -0.3. Okay, so that's my y-intercept. That is my y-intercept there. I've got 0, comma, negative 0.3. All right, and we can go ahead and graph those. And something weird happens here, okay? I feel like probably your whole life you've been taught that you can't touch an asymptote, but every once in a while with horizontal asymptotes, if you note up here, it says your graph may cross a horizontal asymptote. So keep that in mind. It's a little bit of a kind of weird situation, but that does happen every once in a while. So that's okay. Don't panic. 3, 0 is actually on one of our horizontal asymptotes. Okay, I haven't explored too much into why that's the case, but that does happen every once in a while. Anyways, y-intercept 0, negative 0.3, so that's somewhere in here. Okay, and it's not perfect. All right, but you're noticing that it is going down. Okay, one big piece is that we now note that that one's going down. So we are going to go ahead and finish that one off here. That piece will look like that. And if you wanted to verify, right, maybe plug in one more point, that -1, just to double check. In fact, let's go ahead and do that before I don't know, maybe you're just like, I'm not convinced. Okay, so we can plug in some additional points. We'll do f of -1. All right, so I've got -1 minus 3. Again, I'm going to personally use this factored form up here. So -1 minus 3, and then -1 plus 5, and then -1 plus 2. Okay, so on top I've got -4. On the bottom I've got 4, and then times 1. So we end up with 4 over, -4 over 4. So that's -1 there. And it should have been closer to here. So maybe I need to bend my curve a little bit, okay, just to satisfy those points there. So it's a little bit closer to that asymptote. Okay? All right, and then some more points. So I'll go ahead and tell you, now that we know we have this piece, we're actually going to have a mirror image kind of over here, okay, and then we're going to have a funky thing happen up here. But just to verify all that, okay, let's go ahead and test some points. So let's do maybe this section over here first. I'm picking x is -8 and then -6. So let's try those. -8. To save you some time, save you the convenience, you're going to get 11 out of 18 here. You could verify that. Yeah. Let's verify it because I don't know. I think it might be negative. I'm going to pause it. Yep, like my gut told me, it is negative. So there it is. You could also verify f of -6. You could plug all that in and get out a -2.25. All right, so it gives you some points here, or I gave you some points. So, 11 over 18, that's about 1/2. So, you've got a point in here, -6. You've got that -2.25, so somewhere in here. And you can continue, right? That one doesn't cross. I know I kind of drew it poorly, but it does get very close to that asymptote. And if you wanted to continue the asymptote, you could, but it goes something like that. And then what you'll find, again, you could verify these, but it's just to find some more in between here, right? So you found some on this side, you found some on that side. We've got to find some of these. So maybe f of -4, right? -4 and then -3, those seem reasonable. And so we could do that over here, f of -4. Again, you can verify it, but 3.5, you should get that. So you end up with a point there, -3, positive 3.5. So we're here, -4, 3.5. And then f of probably -3 is what I said. And so we'll have, you end up with, let's see, 6. We'll just do that one together. So we've got -3 minus 3 on top. And then on the bottom, we've got -3 plus 5. That's 2. And then -3 plus 2. That's -1. Okay, so on top you end up with -6 on top, but then over -2, so this one actually gets you exactly 3. All right, and again, I'm just plugging this in to my factored form is where I'm getting those numbers from. I'm plugging those values in and getting out a particular y value. So I got -3, 3. Okay, so -3, 3. And if you really wanted, you could verify one in between. What you're going to end up with is that with those vertical asymptotes, you got something that looks like that. And that is kind of estimating graphing polynomials, or graphing rational functions. All right? Graphing rational functions. Boy, I let a lot of words slip today. Wasn't my best. But anyways, hopefully you guys are getting the point here. Using this sheet is crucial. Okay, using this sheet right here is crucial here. It's just a very important step-by-step process in order to verify all of your rational functions. Okay, that's all I got. You guys have a great day. Take care. I will see you later.